Hello and welcome. My name is Luke Rule, a fifth year electrical co-op student from Central Queensland University. Today I'll be presenting a training video on the PowerFactory load modelling software. After this video you should be able to activate a project, set up diagram colouring and layers, run a load flow, modify the graphic window and tabularize results. Energy Queensland is a government-owned corporation founded through the merger of Energex and Ergon Energy. Energy Queensland provides power to 2.1 million customers across 1.7 million square kilometres, as well as supplying 33 isolated systems. With the continual growth of the network through new subdivisions, distributed generation such as PV, as well as other unique challenges faced in urban and rural Queensland, planning and forecasting is critical for Energy Queensland to ensure that every customer can keep their premise powered. Accurate digital models of the physical network are used to simulate augmentations of the network to ensure that asset ratings are not exceeded through new customers, connections, and switching events, calculating harmonic distortion, checking voltage profiles along feeders, and proposing voltage regulators based on findings, amongst others. PowerFactory is a relatively new load modelling software being introduced into the Ergon Energy side of Energy Queensland. One significant advantage of this software over many other existing softwares is the functionality to simulate non-symmetrical loads, whereas previously most softwares were limited to balanced load flows and fault studies. After opening PowerFactory, we are presented with a window without an active project. To activate a project, you'll need to locate and open the data manager shown in the top left-hand corner of the window. For this video, I'll be opening an example project that I've created. Projects can be activated by right-clicking the project and then selecting Activate. The data manager will need to be minimized or closed. We can close the data manager for now. We can maximize the graphical window by selecting the icon indicated in the middle of the toolbar. This will minimize the output window. PowerFactory can color network elements based on various different parameters. In this video, we'll be coloring based on feeder. By selecting the color palette and ensuring that the other tick box is selected, dropping down the second drop-down menu, we can select feeders. As you can see, this project has 3 feeders. Clicking the color settings will allow each feeder color to be reassigned. Using the automatic color assignment, we can reassign each feeder to a unique color. However, these can be manually set by double-clicking the color block next to the feeder. We can now see in the graphic window that it has been updated to show these feeder colors. PowerFactory allows different variables and parameters to be shown or not through the layer setup. Opening the layer options in the middle of the toolbar presents this window. The left box shows the layers that are currently visible, while the right shows the invisible layers. Layers can be shifted by selecting the layer or layers you wish to change, then clicking the arrows in the center. In this example, I'll demonstrate setting the object names to invisible. As you can see, the names are no longer showing in the graphic window. Running a load flow is performed in PowerFactory by selecting the icon on the left side of the toolbar. As mentioned earlier, PowerFactory can not only run a balanced load flow, but can also run unbalanced load flows and DC load flows. DC load flows can help with systems that do not converge whilst running a balanced load flow. Load flows can be configured to allow automatic tap changing, shunt adjustment, etc., with many more advanced options being available through the left-hand column of the window. Clicking the execute function will run a load flow with the selected options. We can also drag up the output window from the bottom and see that the load flow has converged in 2 iterations. Minimizing the output window again, we can right-click on a result box and edit the format to show many different variables. In this window, we can right-click in the free space, append a row. Now when we edit this row, we can see all the variables that can be selected to show in the graphic window. For this example, I'll set the line to ground voltage magnitude to show. The preview box below shows how the variables will display in the graphic window. For each variable, the result box can show the variable name and the units, as well as the equal signs for formatting. Again, the preview box shows the changes you've made. The result box has a static width. The full set of text can be shown by opening the layers, like we did earlier, and going into the configuration tab. Clicking the drop down option and changing the layer to the results, and then clicking adapt width. This will adapt the width of the result boxes to show all the text contained within. For the two highlighted buses, we can see that the result boxes have become cluttered. This can be remedied by extending or moving the buses. This can only be done while freeze mode is not on. Freeze mode can be toggled by this icon in the top left-hand corner. An indication that freeze mode is on is that the component toolbar on the right-hand side will not be visible, nor will the dot grid. With freeze mode off, we can select a bus and then drag the red squares to extend or shorten the bus. I'll do this for both buses. For larger models, it may be more sensible to have the results in tabular form rather than in the graphic window. Clicking on the relevant objects icon, next terminals, and then finally flexible data in the window that opens. This window shows the results of the load flow. If more variables are needed to be shown, we can define what results are shown in the table by clicking on this icon. This is the same as the result box formatting we did earlier. Again, I'll show the line to ground voltage magnitude by checking the tick box. As you can see, the line to ground voltage magnitudes are now showing for all 5 buses of this system. Please note that transformers will have different set of variables such as loading and copper losses, as well as lines having different variables as well. Each one is individually configurable. Yada yada yada. Something to note that in the flexible data window, the variables listed here are specific for terminals. Data objects that are different to the terminal, such as transformers or lines, shunt elements, PV systems, anything at all that has data calculated for it, they will have different parameters and can all individually be set up to show different parameters such as line loading, copper losses of a transformer, etc. Thanks very much for attending this training presentation. Any further questions are welcome to be forwarded on to myself. I hope this video has helped with the basic setup of the graphic window and for how to run a load flow on an active project within PowerFactory. Goodbye for now.